Okay, so we've got this scenario here, and I'm going to end up, you actually just saw a quick glimpse of it, but we're going to end up looking at this problem in three ways. We know the tape method, we've been exploring with the fraction method, and now I'm going to introduce a new way looking at it as a table, okay? For every 16 basketball players in Crystal County schools, there are 48 soccer players. So you can see the diagram. If there's 16 basketball players, that means there's 48 that also do soccer. I'm not sure why that was blocking. Okay. If the ratio remains consistent and there are 64 basketball players, how many soccer players are there? So we'll look at this, and you could kind of take this diagram if we wanted, and we could just kind of rotate it, and you could maybe kind of start to see the tape, right? So the tape is this. It's right here. So the tape is, I could look at how many 16s go into 48. Okay, so I get one 16 to go into 16 and three 16s to go into 48. So what we're looking at is a 1-to-3 ratio. So that being said, if I make this my basketball players and this is my soccer players, and I kind of cut this out, there's a 1-to-3 ratio. If I had one group of 64 basketball players, then that means I got three groups of 64 soccer players. So how many soccer players is that? I can do 64 plus 64 plus 64, or I can do 64 times 3. So 3 times 4 is 12, carry the 1. 3 times 6 is 18 plus the 1. It's 192 soccer players. So how do we do this with the fraction method? Well, looking at the information we have, we had 16 basketball players for every soccer, right? So I'm going to do basketball over soccer. I'm going to declare what units are going where, and then I'm going to create my fraction, right? So I've got 16 basketball players to 48 soccer players. And I know I'm going to eventually have 64 basketball players. So we're taking 16 times a number to get to 64. So this is kind of grouping our last unit together too. We're saying 16 times some number gets me 64, right? And we need to find what's that missing number. So we divide by 16 to undo the multiplication, and we find out what would that number be that we're multiplying by. So 16 or 64 divided by 16 is 4. So our hidden multiplier is 4. So that means we're going to multiply down here to find our mystery number. We're going to multiply it by 4. So just to double check, we're going to say it's 48 times 4. We hope that the answer is 192 because that's what we already got, right? So 4 times 8 is 32. 4 times 4 is 16. 16 plus 3 more is 192. So again, 192 for the soccer players. And last way that we're going to introduce to you is a table. So I'm going to put my basketball players on my table, and I'm going to put my soccer players on my table. This is very much like the fraction method, okay? If I have 16 basketball players, I have 48 soccer players. If I have 64 basketball players, I have what number of soccer players? So we look at our table and we say, is there a pattern? The pattern I see is I multiplied by 4. 16 times 4 got me 64. So I could take that same pattern and multiply 48 times 4, which we already did over here, and we're going to get 192. So set it up as a fraction method or set it up as the table. We're going to find the same pattern there. Okay, but now we're going to start to be looking and be given some ratios and or some tables and saying, is there a common ratio? Can you look at this and would you be able to tell me what the ratio is? So what are we doing to 2 to turn it into 4? What are we doing to 4 to turn into 6? Like, is there some pattern going on? So that's what we're going to start looking at, okay? And that one wasn't 100% correct. It was a quick example, but just letting you know what direction we're going with these ratios and how we can further